Myself and Leonardo here are here to talk about the JSR that we're involved with in the Java community process, which is JSR 363. In case any of you are on Google while we're talking, you can look it up. It's the units of measurement. So we can introduce ourselves first, and then we'll go on to talk about the software, the API, and get onto a demo of it towards the end. So, firstly, I'll introduce myself. My name's Krista Senior. I'm a product manager and senior engineer for Snap-on Tools, if anybody knows Snap-on at all. Working primarily in the automotive sector, and I'm based in Manchester, UK. And I'm an expert group member within JSR 363, and also, for my sins, an Eclipse committer. Leo?
Yeah, I'm Leonardo Lima. I'm from Brazil. I am a computer engineer by trade. I started programming. Now I'm CDO at my company, V2Com. And I'm spec lead at the JSR, together with Werner Caio and Jean-Marie Daltel. And I represent my company at the JCP Executive Committee, too.
Okay. So, JSR 363. It's all about measurements. So I'm going to start with a fairly basic introduction to what is a measurement. So my friend Leo here came all the way from Sao Paulo to be with us today. So I thought the best example to start with would be to look at a measurement with a measuring tape of how long or how far it is from Sao Paulo to London. So 5,888 miles is a measurement. The second part of that, the miles piece, is a unit. And anyone who doesn't know that, I think, is in the wrong session. So, why do we need JSR 363 to represent things like that in Java? Well, there are no specifications or standards in Java for handling units like that. There's nothing available to us other than floats and strings and some custom types that we might have developed ourselves to package up that unit of measurement into a single object. But there's no way of sharing it across teams or across products or across anything like that. There's no standard for it. It's also an inherently tricky area to get involved in, dealing with units of measurement and quantities and everything else that we'll see later. There are plenty of opportunities to get things wrong when it comes to rounding and units and so forth when you're handing units of measurement around inside a software application. So a library in this area, and a standard library for Java or a standard API for dealing with this stuff, can help us as programmers to avoid some of these common pitfalls. So the idea here is to give everybody in this room a standard library they can use to represent units so that they don't have to make these mistakes in their code. So if we look at the tin pot example that I gave at the start here, typically what we would do today, or hopefully you won't do it this badly, but it took us quite a while to write a piece of code quite this bad to represent units. But I have seen things like this in code in my time, so it's not too unusual. We tend to represent the unit, the measurement part of things as some kind of literal. In this case, an integer, 5,888, and that's in miles. And only the comment says that it's in miles. Later on, we've got a float which represents the speed, which again, only the comment tells us it's in kilometers per hour. And if we want to try and work out roughly how long it would take Leonardo to get here in his plane, doing whatever kilometers an hour it returns from that function, we've got an ETA function here which divides the distance by the speed and prints it out in hours. Now, hopefully everybody in this room can see all the mistakes that we've made here to try and get that. Obviously, we've got kilometers and miles mixed up, so you're going to get some strange answers back from that function. So we've got interfaces and abstract classes within our API. There's a reference implementation available which implements those and gives you out-of-the-box functionality. But basically, it's an API, meaning that multiple people can implement that API. So there's a project within Eclipse, UOMO, that will implement this stuff. There's also the JScience API, yeah, which Jean-Marie's involved with.
JO API as well.
JOE API. So there's a few different implementations of this API, and hopefully with our TCK, we'll be able to make sure that they all do the same thing when you call them. So I thought I would go through some of the core theory and concepts behind the API. So this isn't the code piece, this is the science piece. Hence we've got Beaker over there on the diagram. So the first thing is units. The Oxford English Dictionary defines a unit as any determinate quantity, dimension, or magnitude adopted as a basis, or standard being the key word, of measurement for other quantities of the same kind and in terms which their magnitude is calculated or expressed. So I've put down a few units that most of us will be familiar with down here. And the definition of them is actually a little bit more complicated than most people think. So a second, the traditional definition of it is, of course, as a subdivision of a day, whereas in actual fact, it's defined as that rather complicated definition. I'm not going to read that number out, but the number of periods of transition between two states in some radioactive isotope. Kilogram is a really more interesting one. This is a properly nerdy subject when you get into it. But the kilogram is actually just a lump of metal in France, and all of the other kilograms are based on that lump of metal, which is inside 2 glass jars and kept under lock and key. But there is no other definition of weight or mass, sorry, than just that mass in France. All the others are based off it. And then the meter is defined as the distance that light would travel in that minute amount of time. And it's actually derived from the other unit. So you can see that meter is obviously derived from second internally. So units themselves aren't fairly simple things to define. They are quite complicated beasts, and there is an awful lot of science behind this in things like the BIPM and the SI Institute. So a standard measurement, then, is what a unit represents. And as Mr. Tannenbaum wrote in his book, the nice thing about standards is that there's so many to choose from. So if we take something like meter, or as our American friends would spell it, meter, and other parts of Europe spell it like that as well, actually. Then we have the SI prefixes around that, all representing different units of different sizes. Then most of us are familiar with a mile, or we think we are, and the yard and everything that hangs off it. But in reality, there's a bazillion representations of what a unit of length could be, from including my favorite, the Scots mile, which is different from an English mile, but only just. And there are various other units around here, including things that represent very, very large distances, like light years and parsecs, to very, very small distances, like angstroms, and even the poppy seed, which, again, that's an old medieval English unit, which we don't use anymore. But you never know, you might encounter a piece of code that deals in poppy seeds as a unit of length. Yeah. So we have a system of units, and within the standard API, we're obviously sticking to this because this is what the international world of science and engineering uses as its basis for all measurement. So the System International, the units, the SI, as everybody knows it, is the basis, and it's fundamentally what we've built into the API as being the basis of our API as well. So within SI, there are obviously standard units for the 7 base units of time, length, power, etc. There's also standard prefixes, kilo, mega, giga, and so on. And there are standard dimensions. Now, dimensions is where it starts to get fun and interesting in the world of units and quantities. Dimensions allow analysis of a quantity by rational powers of the 7 fundamental dimensions. So these are the 7 fundamental dimensions as specified in the SI system. We've got length, mass, time, electric charge, absolute temperature, amount of substance, and luminous intensity. And with those 7 base dimensions, we can compose any other of the dimensions represented by the other quantities. So examples here. Speed, everybody knows from physics, is length over time, but its dimensions, therefore, are L equals 1, T equals minus 1. And you can see that in the unit when it's written meters per second. The S minus 1 is the dimension length, and time to the minus 1. Acceleration, being speed over time, is the same thing, but over time again. So now we have seconds to the minus 2. Force, mass times acceleration, from our Newton lessons in physics. We get M1, L1, and T2 for that. So you can see how you can build up the dimensions representing different quantities and compare them. Now, all units that that represent force share the same dimensions, which allows us to work out whether the thing we have in our hand is the same as another thing that we have in our hand. So the dimensional analysis is a key component of what this API does to help keep you on the straight and narrow, even when you've created your own random units that represent barleycorns over parsecs or whatever they happen to be. I thought I'd chuck in a complicated example, which is I have no idea what molar entropy is, but its dimensions are just about all of them written in different things. So it can get fairly complicated, dimensional analysis, but it basically always deals in a vector of those 7 dimensions. Then we come on to quantity. Quantity is an area that we've wrestled with inside the API because we'd like to have a class that represents each quantity that we encounter in our daily lives. Now, there are some standard ones in SI that are obvious, and we'd like to include them, like time and length and speed and so on. But realistically, the list of quantities in the universe is infinite. We will never finish our job of writing down all of the quantities and adding them into our API. So things like eggs per carton is actually a quantity, and it has its own dimension. Sheep per hour, and even bits and bytes are kind of not really represented very well by the SI standards, units of information. But we have taken the SI 7 tables of the SI quantities, and they are included in the base API. So I can't remember what they all are, because there's like 35, 40 different quantities in there.
It's too much.
Yeah.
We had a lengthy discussion figuring out which one should go, if the 7 plus the extras.
A discussion that rumbled on in email. I mean, to be honest, that one's been going on for years, as to which quantities should be in and which ones should be out.
But I guess we're finalizing that.
Yeah. If anybody has a quantity they're particularly attached to and like to see in the specification, then get involved. So, learning from the past to try and help us avoid some of the mistakes, I thought I'd give you some examples of what can go wrong in the world of units. So if we start with the Star Wars initiative in 1983, if anybody remembers that, Ronald Reagan came up with this idea of having lasers in space to shoot down Russian missiles. And while they were testing this, they decided to get a laser and point it at a point on the top of this mountain. So the definition was you need to point your laser from the space shuttle at a point 10,000 feet above sea level. And when that got entered, it got entered as 10,000 nautical miles above sea level, and they shot a laser off into space, and nothing happened, and their experiment was a failure. And in the subsequent analysis of how did we manage to waste all this money, it came out that they typed in the wrong units into the computer. It's not the only one, sadly. The NASA Mars Climate Orbiter from 1999 was meant to glide gracefully around the Mars surface, analysing the climate of the planet. Instead, it analysed it rather closely and burnt up in the atmosphere of Mars and was never seen again. And I think it cost $125 million down the pan in getting that probe all the way to that planet. And the findings were that people used the wrong kinds of units again. We had US English units, e.g. inches and feet, in one part of the computer program, and metric units in another part of the computer system. So millimeters into inches as a number gets you that $125 million worth of failure. The Gimli Glider is another example. Without going into all of the details, effectively, it was I think it's a de Havilland, it's an aircraft that ran out of fuel mysteriously, and the pilots weren't aware that they didn't have enough fuel, and then they had to glide, which is an interesting concept in an aircraft that size. They had to land at a runway they weren't expecting to. They ploughed off the end of it, ripped the undercarriage off. 2 people were minor injuries, and everybody else had to get down the emergency exits to get off. But the main cause of that was the guys putting the fuel in used 1.77 as the density estimate for litres from weight of fuel, whereas in actual fact that number was for pounds per litre, not kilograms per litre. So again, Duff unit equals big cost. And then this is my favourite. In 2001, the escape of the quarter-ton tortoise called Clarence. So Clarence was at the Los Angeles Zoo, and she was lent to the Exotic Animal Training and Management Program at Moore Park College in California. And when they gave them the specifications for the, what do you call a thing that a tortoise lives in, a hutch compound, when they gave the specifications, they said she weighs 250, and they didn't specify the units. So they built a compound to cope with a 250-pound tortoise, and the 250-kilogram tortoise walked through it like it was matchsticks, basically, and wasn't there. And off she went round Los Angeles. So these are examples of kind of confusion around the units in an application, as in inches instead of miles and so forth. And they're pretty easy to make, particularly when you don't have something to represent the units that's coupled with the value that you're measuring. But there's also ambiguity on the unit itself. I mean, people say gallons all the time, like there's only one kind of gallon in the universe. In actual fact, there's dry gallons, liquid gallons, US gallons, UK gallons. We have like 5 or 6 different flavors of gallon out there. And then day is another one. Everybody thinks there's just one day, whereas there's quite a lot of different definitions of a day. There's the calendar one, and then there's the one that everybody uses in physics. And then degrees is a particularly bad one. People often think that degrees just implies an angle, whereas it's also a temperature measurement as well, of course, degrees Celsius and degrees Fahrenheit. So even when you write down the unit and put it together with the value, it's not always unambiguous as to what you intended. And then the other mistake that's quite frequent when people do their own units is getting the wrong conversion factors. So you can see the pixel to inch thing here is just being used the wrong way. So you're ending up with a really big number when you should have a really small number because you just got the wrong conversion factor in. The thing about these mistakes is they're really hard to pick up in the code. And even unit testing doesn't necessarily pick it up because your tests are going to assert things that you've already put into your code. So it's tricky problems to deal with. So to the code then. We had our primitive example of how not to do it with Leo's flight to get here today. But what does it look like when you do it in JSR 363? So we have a quantity class that represents something that you're measuring. And it's genericized, so you can give it the quantity type that you're measuring inside that quantity. So a quantity represents a measurement and a unit coupled together. And it's also typed with the kind of quantity that you're measuring. So length is a kind of quantity. So here we've got a distance represented by 5,898 US miles. So again, being specific about which mile, not just mile, but that mile. Then we've got the airplane speed. This is where it gets interesting because now we're getting back a quantity of type speed from a function, and it really doesn't matter what unit that returns it in. It's a quantity of type speed, and we can convert it into any speed we need inside our algorithm to process that. So it's a generic container for speeds that we can use within our application and not get the maths wrong, basically. And then time, we divide one by the other, and internally it will create a unit that represents miles divided by whatever it is that's inside speed. So we end up with a time unit coming back from that, which would probably be hours in this case, given that it's in miles per hour and kilometers per hour usually. And then the final thing that we can do in here is print things and unit formatting. So when I print ETA out as hours, it will render it like you see down the bottom here. And again, out-of-the-box rendering and formatting isn't necessarily what you want. You may want to have your own custom formatting in there, and there are classes in the API for you to get more control over what the formatting looks like. So anybody who has to deal with physical quantities and need to handle measurements and working for a tool and test tool company, we do that quite a lot, so I'll be one of them. Anyone with inadequate models of physical measurements that can lead to programmatic errors. And to be honest, even the same API extends into money now as well, doesn't it, I believe? So we're also using the units to represent different kinds of currency. Embedded developers is a big one, to be honest with you. One of the main applications we see of this API is in very small devices that are very close to the thing being measured. So typically the kind of devices your company produce, really, for doing measurement of power in people's homes and so forth. Yeah, anything like this IoT era, it's all about getting data from the environment to the systems. So we are always measuring something, either temperature, air quality, tire pressure, anything. And it's very important because you have like different values, meaning almost the same thing. For example, electricity, you have active power, reactive power, demand, consumption. They are very close, and if you don't pay attention to the unit, you end up having a very mess with your code. So it's important to get the units right so you don't have to spend a lot of time debugging or validating with your client, for example. So, okay. So if we look inside, the structure of JSR 363 and what packages we have. It's not a very big standard, to be honest. It's only 4 packages, and 3 of those are optional. So the JAVAX measure package really provides the core, which is the fundamental quantity type, unit, and dimension are all represented in there. The different quantity types that we have out the box from those tables from the SI are all in the JAVAX measure quantity package, which is optional because, again, we don't necessarily need that in embedded applications where we're working with kilobytes instead of megabytes. So the idea here was to try and give it these 3 jars as optional, basically. If you don't need them in an embedded application, then leave them out. So really, JAVAX measure is all you absolutely need to make use of this API, and that, how big is that?
It's 4 interfaces, I guess.
Yeah, so if it's a kilobyte, I'd be amazed. And the very small devices along the bottom here, these are all some of your devices.
Yeah, so that's the kind of devices we developed in our company. All embedded devices that attach to something. So for example, the first one is a data concentrator for the second one, which measures energy inside a breaker box. And the third one is a device that attaches to a water meter and sends data over GPRS networks. So all these kinds of different devices that runs Java, and we want to be able to reliably read the values and send it over the networks. So that's why we're really interested in that. And since I began in a company 10 years ago, it's always float, 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 float. It's float, value, long timestamps. So we have new data time APIs. Now we need some units now as well.
So the other packages, the format package provides a unit format API, which is really just like date format or any other formats you've seen inside Java. It takes one of these quantity objects and will turn it into a string, or take a string and turn it back into one of these quantity objects. Where it gets complicated is the format you use for units, because how you represent units as a string is an entire science in its own right. So we have some implementations in here that we can provide out of the box, like UCUM, which is used in the healthcare industry quite extensively to represent primarily things to do with bodies and blood cells and things like that. There are also schema.org, use another one to represent, that comes from the, there's a standard with like 1,000 different definitions of E123 means this unit and so forth. So there are quite a lot of format standards out there. This is really just the API to get at one of those objects when you have one. So, and I think, what does the reference implementation do? It's just...
It's specific. Yeah. It's specifically built for it. So
none of the above.
Yeah, normally must.
And then the SPI piece is really providing services and allows you to detect implementations of this stuff and make use of them. So it's the bootstrapping process for how do I get a particular JAVAX measure library at runtime. So we'll go on to look at a demo of some of the code on your machine. We should explain a little bit about what we've tried to pretend that we're doing in this application. So we've got 2 scenarios really we're looking at. Do you want to talk about this? Or do you want
okay, sure. Okay. So as I mentioned before, we attach stuff. So do we have a pointer? No, right? Is it a pointer?
No.
No. Okay, so let me cross over here. So one of the things that we do in our company is measure energy, so electricity in our home. So this is a breaker box that goes next to your main meter. And eventually, you're going to end up using energy and not knowing where exactly you're wasting your energy, for example. So if you have defective air conditioning or defective refrigerator unit, you may not know that that's the cause that you're getting higher bills. So we are creating a new product that's submeters that, so you the device here, attach it to some clamps, and this is very big, like 40 inches high. It's almost like real life size. So this reads this current and voltages on this box and send this data over wireless connection. So we want to be able to read this data and know that I'm reading currents on one of the sensors and voltage on the others in the other sensors. And right now, without the JSR, we just have float, like 6 floats. And we can just say one plus the other is wrong, one times the other makes sense. So that's we want to be able to avoid the unity ambiguity. So we know these sensors are voltages and these sensors are current. And also, we want to be able to make sense of what you're doing with these values. So, you want to show the other one as well?
One, yeah.
So, we not only read here and also send it over to somebody else. So the data, IoT is all about getting data from the device and sending data up and doing something with the data. So on the receiver, we also have to make sure that this data is the correct unit, and also you don't have loss of precision, for example, or loss of unit value. So unit value, no. What's the correct unit for that value? So we want to make sure nothing is lost on the way. So I cannot walk around with these, like airport security don't like it, so unfortunately I could not bring it. So, but I will pretend that I have something like this and just right from scratch what it would be like to connect to some kind of these and translate using our API. Okay, so very hands-on demo with So I'll start from scratch to make more interesting. So I create a new Maven project, and we're going to show on the end how you can download the API in their reference implementation. We have that in Maven repositories as well, but it's much more fun if you can download the source code. It's really not heavy, and just start working with it. You're going to find bugs, and you can always help applying some patches, sending to us. So I'm going to DevOps demo, artifact ID, submitter demo. And I'm going to depend on my API. And also in any implementation, I'm using the reference implementation. But I could use other APIs as Chris mentioned. There are some others as well.
It's at this point I point out that the reference implementation is not finished.
Yes, so you see 0.8 snapshot, so it's not finished, and it may take a while for us to finish, but...
If everybody in this room helped, it wouldn't take quite as long, would it?
Sorry?
If everybody in this room was to help us get it
wouldn't.
finished.
Yeah, it will be much faster. Because, especially to get all the input that we need for, how do you say, what should be in and not. So we add stuff and then we have to remove it, and it also targets Java ME and SE. So Java ME development is very different than just Maven and everything. So this is part of it. I need just to make sure it's Java. Let me copy the properties to make sure it's Java 8. So we are targeting Java ME and Java SE 8, even though the API itself is compatible with Java SE 5. As you can see here, the API compiles under Java SE 5, but we are using Java SE 1.7 as the reference implementation. But let's work with Java ME 8, Java SE 8, sorry. So, oh crap, Maven update project, Java SE 1.18, great. So, really simple. So all IoT projects eventually start with a class that represent what is that you are measuring. So, normally, very very creative measurement, and this measurement is really a timestamp. So I'm a guy that say don't use primitive values. So I'm not going to do private long timestamp. So I'm use a neolocal date and time class to represent time, and I'll use my quantities for electric current, it will be my 3 current sensors. So channel 1, channel 2, and channel 3. And private quantity electric potential as the voltage. So we have a 3-phase sensor. Okay, so we just do the getters. We do the setters as protected because we don't want anybody setting this stuff. And on a gateway, I would have my class connecting to the submeter and getting this data. So it will have a serial number. And you will have a public measurement, get actual measurements that will return I'll just so these would connect over wireless, connect to the device and read over, but we don't have that here, so I'll just do set timestamp, local time now. It's well, let's pretend it's just one phase, so phase, and this is where we say quantities, get quantity. I'll do, just to make fun, a random value. And I'm gonna pretend that my sensor is like low precision, so it has 1 volt precision. So I'm gonna and float. Oh. Math round. Do I get and I'm using vote from SI library to represent my phase. And let's do phase A. Quantities, good quantity. Math round times 10. I will use ampere as it's a current value. Electrical current, so not phase A, so the current channel 1.
That rather neatly demonstrated the purpose of the API, highlighting the fact that you were trying to shove a
really nice. So yeah, let's do that again. I didn't even notice. So I'm trying to set an ampere value to a phase. So you cannot set that because ampere is not electrical potential, it's electrical current. So it prevents you to make some mistakes that would only show up in the later part of the demo. Yeah. So in my gateway, I would have code that would periodically query these meter submeter, and this is actually what's the response. Let me get that out of the way. So I would connect to the submeter. Here is just submeter. Submeter. Now I have request measurement. And here, now comes the fun part. I don't want to report back everything as is. I want to send over to my system just the demand power. Instead of sending the current and volt, I want to send what's the watt hour, that's consumption. Or I can send watts as demand to the system. So I'm doing some operations on these values. So
it's like kilowatt hours, you mean?
Yeah, so in the end, it can be kilowatt hours, can be joules, can be some kind of energy, or it can be demand, or it can be something else. So it's all related to electricity, but they all have something specific about them that it's what the user wants to see then. So for example, if you are an industry that you pay by demand, you don't want to go above a given threshold. So it's important to measure your demand more than your consumption. So it's electrical utilities fun to work with. So quantity, electrical potential, volts at phase A.
And that's where some of the errors can creep in as well, because often people see variables like volts and
assume it's volts, yeah.
So it doesn't have to be.
It doesn't have to be. And he'll say channel 1, and so I'll just print stuff out. So phase A is channel 1. Now I know that if I multiply potential per current, I'll get power. So quantity power, channel 1 power, equal volts, multiply channel 1. And it will complain because it doesn't necessarily know what kind of unit comes out of this. So that was one of the problems with when you're making a specification. Do you want to be like hand guiding somebody through, oh, you cannot make a volt multiplying by temperature and getting energy? So we said, no, the guy writing the code should be able to verify he's writing something right, but not necessarily if he wants to do something bad, he may be, because he may want that unit for some use case we are not seeing. So it has powers of generics, but you have to do some casting as well.
Also, at compile time, you can't work out what type that should be.
Yes. So
but if you do get it wrong, you'll find out pretty quickly.
Yeah. So I'll just run it right now, just so we do. So this would be the first part. I'm doing some calculation, and I know that I'm getting power. So if I want to do demand, I can just run this. And they're going to say, okay, if I have 119 volts for almost 5.7 amperes, I get 677 ampere volts, which is almost like watts, but it's not necessarily like, because there's reactive power, active power and stuff. But
it's the same dimension as
it's the same dimension, so you're getting stuff corrected, and you're safe that you're not mixing stuff up. So I can do energy, and I know that if I take power over time, not over, like times time, so it's channel 1 energy. Channel 1, I'm going to assume I know that this is over 1 second, so multiply quantities. Get quantity 1 SI seconds. Again, cast. It will, as I'm multiplying by per 1, the number is the same, but now the meaning is totally different. Now I have consumption instead of active demand, So, whoops. So now I have the same values, but different units. So this is important too, because if you do something with this one, it's totally different than doing something with this other one. So this is the kind of type safety we want in the code, so you don't mess with different stuff, and it will take like 1-2 days debugging just to figure out what's currently wrong. So just because we're maybe running out of time for questions, I'll just do, if I want to wire these to my server, so this transmit, instead of connecting somewhere, I'm just putting this in a string builder. So I would say append channel 1 energy, get value. Append, say my protocol is using semi-comma, and append, and I can get simple unit format to actually format that. And this is part of where the API is not actually complete, because formatting, so as he said, formatting is very complicated. So if I do it, it will break. So instead of using the energy as is, I will use channel energy is channel energy 2. I will use the same unit, the same quantity, but in another unit with this joule. So it allows me to turn this, which is something else, to joule. If I take this, oh yeah, I have to comment this out. So now it's something else, and if I try, for example, to convert this to other unit, it will not electron volt. No, it should complain. Yeah, so maybe electron volt to something that I don't know. That's the same thing. So this is energy, and Becquerel is real activity, so it doesn't allow you to. So converting to joule and format the unit. Oh, sorry, not. I forgot. Unit channel 1, get it. So over the air, I'll have this string sent. Oops. Yeah, this can this throws an exception because it can have an IO exception appending this to your appendable. So over the air, I'll send this, and on the receiving side, we do the same. So for example, I'll have split so yeah, float value. The value itself, it's just float parse value. The unit at instance parse parts 1, and now I can do quantity energy read from meter equals quantity, get quantity value unit. There we go. So received and read from meter. So in the end, I reconstruct my object, and you can do this like in bazillion number of ways, JSON, REST, or whatever. But we are not caring much about how you transmit data, but more as in how do you know that you're not losing information about your unit. So yeah, that's...
The key thing here is that the interface to the format is the same regardless of what format you're using. So if you're using UCUM or you're using something from the SI or one of the other standards, even XML standards that exist for representing units, you're using the same API to create the string at the end of the day and parse back the string. So what we're trying to do here, remember, in a JSR is just specify the API. The implementations of that API govern what that string is going to look like. Well, and we will tell you which ones exist, but yeah. Yeah, so that's, thank you very much.
Sorry.
That's our demo. I'll just quickly go through one or two things, which is the call to action. So obviously it's still an alive or an active JSR, and everybody in this room can get involved in it. We're participating in a few adopted JSR programs, so if there are any other Java user groups represented, then they're welcome to join the expert group and help us develop this thing and help us.
Yeah, for example, Ottavio here is helping us with the SC part of part of the code that I ran. Ottavio helped us write. So
yeah, and even if you don't go as far as participating formally in the JSR, there's still the code on GitHub. There's our issue list on GitHub. There are mailing lists. There's lots of different ways to get involved in the project and help us make it better. And we're always looking for new ideas and use cases. I mean, we represent kind of engineering and science use cases amongst us, but if there are any others that you can think of and want to bring along, then please participate. The important thing is where we are in the timeline. So there is still plenty of time to get involved in helping us formalize this public draft towards the end of the year before it goes out into the JSR. Hopefully once that final draft's been published and approved by the JSR process, then we'll be looking at early 2016 before this becomes part of the JVM in terms of the JCP. And then I've put some links in here, really. I mean, if you want to download the presentation, all these links will take you to our Google Groups, mailing lists and so forth, and also the project website on GitHub and so forth. But if you look for units of measurement, I think it's on GitHub, you'll find it.
It's units of measurement right there. It's units of measurement on GitHub.
And if you want to get hold in building it, it's pretty easy, actually, because there isn't an awful lot in there. If you clone those two repositories out of GitHub, and then Maven compile install, you'll have a working copy of it on your file system. If you want to do it for ME, it's a bit more complicated, and right now, as we stand in this room, it's broken. So please help us fix it and get it back on if anybody's an ME expert in here. So, are there any questions? We've got kind of 5 minutes left, so please.
You mentioned that this is compatible with Java 5, and I saw a time there, and I saw a date and time.
Yeah, so the API itself is compatible with Java 5. So let me go back to the API or classes.
I saw a unit to measure time.
No, so that's somewhat, but not so much. So this time is just the amount of time. That can be seconds, parseconds, can be like time, light years. That's just time. This is just quantity. It doesn't deal with converting this to a point in time or do operations of if I add 5 days to today, where do I go? So that's where the Java date times go. So that's we really specify just on the units.
If you're going to use time as part of an engineering equation, then you need it to be in the same types as we have available here, and that's why we kind of essentially duplicated some of what's going on in the time. But really, we're not trying to do what they're doing. We're just saying we want time as a quantity because it's a key part of a lot of engineering functions and scientific functions.
So the time here is it's time, and it's related to frequency, speed, angular speed, and all this stuff. So this is very specific to engineering, not anything to do with. It's a very simple interface, has nothing, it's just a marker interface saying that's a quantity of time.
There was quite a debate on the mailing list about how do we interface with time in the rest of the VM in terms of different representations of it. So,
and we decided it's a totally different thing.
Yeah. And what was the other question? I think there were two, wasn't there? Or was that it?
Do you measure reactive power?
Yeah, so for example, our equipment, to measure reactive power, you have to do power factor calculations. So it's kind of you have to follow the wave. I don't know if you know electricity. There's the waves of the voltages and the waves of the current. If they are out of phase, you have reactive power. So we wrote the first version of the code for measuring apparent power. Now we have to fine-tune to see all this, that. So we're not yet, but soon. We have all the hardware there. Just need to fine-tune the software to do that. Yeah. Okay, so as we are attached to the current and voltage, we have like both sine waves to work with. Go.
Any other questions?
How straightforward will it be to add your own units and conversions?
It's very, to be honest. The API doesn't police quantities or units. So if you want to create your own ones by either combining other units in interesting ways, that's perfectly possible. And that's technically the preferred way of doing it. So if you did want to have, I don't know, what's a bad unit of time? Barleycorn per
fortnight
per month, then you can do that. And you can create a unit that represents barleycorn per month, and it will be compatible dimensionally with all of the other units of whatever that is. Speed. Yeah. Yeah, there's an interface in there for unit conversion.
Yeah, so
unit converter.
the quantity itself, you have to implement add, subtract, divide by number, by quantity, and depending on what you want, you can just say, I don't support this. I don't support my unit, so throw, if something else comes along, throw an incompatible exception, something like that. But the idea is that we have like these type safing. Your unit will be represented, and you can use it across systems.
Yeah, if you look at concrete implementations of unit, there are some in JScience that are really complicated that you can get into for doing things in different math systems and stuff like that. It gets pretty hairy, but there's nothing stops you adding to it. And it's particularly quantities, to be honest, because quantities is the one that we can't finish. So
yeah, and that's why this package is optional. Like we can't force anybody to implement, especially if we're going for Java ME. You cannot carry radioactivity into a submitter. It makes no sense to have a class that measures radioactivity in an electrical meter, so beats the purpose. Okay, we have...
go on.
It's blinking time up, so...
If anybody wants to leave, you're welcome to.
Yeah.
What's your test coverage like, and are you looking for unit tests?
Sorry, I didn't understand.
Your JUnit tests?
Oh, there are some...
So
the TCK is not... Ready, so that's one part of it. We're still looking after that, but we do have some testing everything using JUnit.
Yeah,
sure, yes, as
the more
many
the
as possible. Yeah, that's and especially so. Yeah, so I don't know how well do you know the JSR process, but there's a piece of software called TCK. That's the test compatibility kit, I believe. Technology compatibility kit, yeah. And it tests all the reference implementation and every other implementation to see if that is actually doing what it is supposed to do. So that will do. This is like a major unit test, testing all the aspects of the API. So that will be like the really good test, and we are gonna have a lot of heavy lifting on that part. So if you want to help with that part as well, because this is testing only for the RI, not the other implementations. So that's kind of the different test, but both are important. Okay,
we better wrap up. Thank you very much for coming.
Thank you.
Thank you.
Thank you.